Hello everyone, in this video I will show you the basic steps of using the Keil software for writing the programs for 8051 based microcontroller systems, right? So for using the Keil software you have to first open the Keil software through the shortcut icon which will be available in your desktop, right? So default project will be opening up, right? So you have to first close it. So you go to project and you click on close project, right? So that's how you have to start off. In case there is any previous project which is opened up, you have to close it, and now you have to create a new project. So for that I will be clicking on project, new microvision project, right? Here you have to give the name of the project, right? So let us say the name of the project is exp1, and now you have to save it in some folders. So here I will be creating a folders, right? I'm creating a folder over here, new folder. I will be naming it as exp1, right? And then project name is again exp1. You can give any name, right? You have to save it. Now you have to select the chip. So for us it is the chip from NXP, right? So in NXP you have to select the controller which you are using. So in our case it is P89V51RD2, right? So I will be selecting P89V51RD2 from the list. So you can just drop down and reach to the position, right? So over here it is this P89V51RD2, right? So you just click on OK. It will ask you to add the startup file to the project. So you say no to it, right? Now you're done with first step, that is creation of the project, right? So now you have to create a new file. So for that you have to go to file, click on new. So that's how you create a new file, and now you have to save this file using Control S, and you can also go to file and click on save as. You name the file as exp1.c if you're creating a C file. If in case you're writing the code in assembly, then in that case you have to specify the extension as .asm, right? So we'll see in this example how to write a C code. So I am having the file name as exp1.c, right? So it has to be saved in the same folder where you have saved your project, right? So click on save. So you're done with creation of the file and saving of the file in the same folder. Now it has to be brought into the environment. So how to do it, this particular thing, you click on this target one, source group 1, and now right click and you say add existing files to source group 1, right? So this is where you have to click on add existing files, and now you have to just double click on this file and close this one. So now you can see that the file is added to the project, right? So that's how it has to be configured. Now you have to write your C program over here. So the task is to blink the LEDs which are connected to port 2, right? So first of all, in a C program you have to include a header file. The header file can be included like this, hash include reg51.h, right? So that's how you have to include the header file. Now you have to create a delay function. So you write void delay int time, right? So you create two variables, I and j, and you use for loop. For I is equal to 0, I less than time, I plus plus, for j is equal to 0, j less than 1275, j plus plus, and then a colon over here, right? So that's a delay routine, right? So now you have to comment it up. This is delay routine, right? So this is delay routine that we have created. It has used two variables I and j, and then I have used loop inside a loop. So for loop is used over here, right? So we'll get back to this particular function later once we use it in the main program, right? So now you have to create the main function. How do you do it? This is void main, right? So you will first clear the port 2. Port 2 is equal to 0x00, all pins low. Then you call it delay subroutine. You give delay and some finite delay you give. Let us say in this particular case 100. Then you make all the pins as high. So you give ff means all the pins of port 2 are going to become high, so all pins high, right? And then you again call the delay 100, right? So that's how the code is, and now you save it by clicking on Control S. So getting back to the code, in this case your main function has the first statement which says that port 2 is 0x00, which means all the pins are going to go to logic low level, right? So this 0 signifies 40 and this 0 signifies 40, so which means all the 8 pins of port 2 are going to be low. Then you call a delay function with 100 value passed to the function delay, right? So when you call this particular function delay, this time variable int time, right? So this is time variable which is of the type integer. It's going to take the value of 100, right? And then this time variable will be updated and it will take the value of 100, right? So the for loop is going to continue from 0 to 99 because it's I less than 100, so it means it starts from 0 and it reaches till 99. And with every for loop of I executing, there will be a delay, because this loop says that it has to stay on this particular line till this condition becomes false, which means it will stay on this line till the value of j variable is less than 1275. The time it becomes more than that, it gets exited from this particular for loop, and then I value gets incremented by 1, and again the process repeats, right? So this is how the delay is introduced into the system, right? And then once it comes out of the delay routine, it makes all the pins of port 2 high, and then again delay subroutine is called with the parameter 100, and the process repeats again and again because we are going to put this particular code in an infinite loop by writing while 1, right? So by writing while 1, this entire set of code is going to repeat infinitely, which means till the time the controller is powered, this entire process is going to repeat, and you will see the blinking effect on port 2. And if you have LEDs connected on port 2, you will see them blinking, right? And if you want to change the time delay, you just need to change the value which you are passing to the delay function. In this case it is 100, it will generate some delay, and in case you want to increase the delay, you just increase this value. In case you want to decrease the delay of switching on and switching off the LEDs, then you decrease this particular value, right? So the programmers can try different combinations and generate the desired delay the way they want, right? So this is how the code is written. Now you have to compile the code, and compilation is very simple. You have to just click on this build button. The shortcut is F7, and it is going to tell you if you have committed any syntax error or not, right? So in this case it says that 0 errors and 0 warning. There is no error that we have committed in the code. It is only going to check the syntax error, not the logical errors. This is something which you have to be very careful about. In case you commit any logical error in your code, then the software is not going to catch it up. It is only going to catch up the language related errors, right? So now the code is successfully compiled. You have to create the hex file, right? Hexadecimal file, because the controller understands only the hexadecimal file. So there are certain steps which you have to follow for creating the hex file. You have to go to project, you have to click on options for target 1. Here you have to select the crystal frequency which is there in your system. In general cases with 8051 based systems, 11.0592 MHz crystal is installed, and that's why we have written this value as 11.0592. In case it is having 12 MHz crystal or any other frequency, you just have to specify that particular value over here. Generally this is the de facto standard, that 8051 based systems are designed using 11.0592 MHz crystal oscillator, which is connected between 18th and the 19th pin. So that's the reason why we are writing this value over here. And then you have to click on output, click on create hex file, and then click on OK button, right? And then you have to build your code again. The time you build it, it is going to create the hexadecimal file in the same folder where you have created your project, right? Now the next step is to identify where the hex file is stored. So it is going to be stored in the same folder where you have created your project. So in this particular case, it is in D drive 8051 book, and there is a folder which was having a name of exp1. So within this exp1 folder, you can see there is another folder which the software has automatically created with the name of objects. When you click on this, you will find this file exp1.hex that you have recently created. So you can right click and click on properties option to see the properties of this file. It is a hexadecimal file. Alright, so this file is going to be dumped onto the microcontroller chip, and it's very important file because the microcontrollers, they understand the hexadecimal file, right? So this file, which is being generated by the Keil IDE, is going to be uploaded onto the microcontroller, right? So before moving on to the hardware testing, let us try to see how we can test this particular code in the Keil environment. Keil provides you this particular feature where you can debug, right? So you just click on debug button and click on this option, start the debugging session, right? So when you start this debugging session, you can see that it shows the status of various resistors right from R0 to R7, special function resistors like accumulator, B, stack pointer, program counter, DPTR, program status word. All those status will be easily seen on this particular window panel, right? So for watching the status of port 2 in this particular case, you have to click on peripherals, click on IO ports, and click on port 2. You can see that this is the status of port 2, which says that all the pins are high by default, right? So now what we need to do is click on debug and click on run button. When you click on the run button, you can see this pattern of LEDs. So it goes to the high state and then it goes to the low state, and this shows that it will blink the LEDs which are going to be connected to port 2. So the code is absolutely fine. This is what we have written. We have made it 0 initially, and then after delay we have made it high, and then again a delay, and the loop is repeating because the code has been made as a part of the while one loop, right? So this is what is happening, and the status of the port 2 is getting updated to FF and then 00 after delay, and then the sequence is repeating, right? So that is how you can actually test your code. For stopping this particular code, you have to click on stop, and then you can go back. You can go back by clicking on this button, start stop debugging session again. When you click on this button, you will be taken back, right? So here is our development mode, right? So it is 8051 based development board. This is the 8051 microcontroller IC, and this cable connects the programmer section to the IC. And in this particular case, since we are programming it using serial ports, so pin number P3.0 and 3.1 will be engaged. And this IC can be easily programmed using a software known as FlashMagic, right? So we will be using the FlashMagic software for programming this particular IC, right? So the other end of the USB, I'm going to connect it onto the laptop and then use a FlashMagic tool for uploading the program. That means the hexadecimal file onto the microcontroller chip, right? So let's do this. So I'm connecting it to the laptop, right? So once I'm done, I'll first check out which COM port it is connected, right? So for doing that, right click on my computer, manage, and then click on device manager, right? And then under the heading of ports, you check which port has been assigned. So in this particular case, it is 24, COM 24, which has been assigned, right? So now let us open the FlashMagic software, right? So in this case, the first thing which you have to be very careful about is that the right IC is selected. In this particular case, it is 89B51RD2, and the right COM port. In this case, the COM port is COM24. In case your computer is going to show certain other COM port number, then you select the right one, right? Now baud rate should be 9600, and then you select the hexadecimal file. In this particular case, it is exp1.hex. Otherwise, you always have the option of browsing it, right? And now you make sure that these two options are checked. Erase all the flash and verify after programming. Verify after programming. Verify after programming. Right. So now click on start, and then the program will be uploaded onto the microcontroller. For doing that, I think the first thing which I have to be very careful about is that this button, the reset button, it should be pressed, right? So now it is pressed. What I need to do is now just click on this button and wait for the flash magic to tell me when to release this particular button, right? So I'll click on start, and now it says reset, so I will release the button, and once I release, you can see verifying and finished. The program is successfully uploaded onto the microcontroller chip, right? So now let's verify the output on the hardware. So now in this case, since we have used port 2, so I'm going to connect the cable on port 2. This is port 2, and the other end of the cable is going to be connected to the LED section, which is this one. So once I connect this, my connections are done. I have to again press the reset button. When I press reset, you can see the LEDs, they will start blinking, right? So this is what we have written, and that the LEDs which are connected to port 2 should blink after a certain time interval, right? So we have created a C code, we have generated a hex file, and then we have used the flash magic tool for uploading the hexadecimal file onto the microcontroller board. So I hope you have understood all the steps which are required for developing any 8051 microcontroller based application using C programming approach. So try it, and happy learning. Thanks a lot for watching the video.